raise your hand just if you can hear me, just so that I know that I'm coming across. Excellent. That's good. I'm getting a few hands. That's brilliant. Thanks, guys. Right. So we've got quite a few sort of analysis tools built into the Revit package. If you're expecting to see any structural analysis, we're not touching on that. We're really looking at sort of just the energy side and what's actually in the Revit package for us at the moment. Now, there has been in the past, Autodesk had a product called Visari, which is a bit like a cut-down version of Revit as far as the massing tools go, and there was some quite nice sort of energy tools in there. Quite a lot of that has now been moved into Revit itself. Some of you may remember a few years ago that they also had a product called Ecotech. That's where the energy tools are actually coming from. So it's a combination of the Ecotech package and also something called Green Building Studio. So we're going to look at some of these tools this afternoon. For some of those of you that don't know me, and if you look on the website, you might have been expecting one of my colleagues, Gareth, but I'm actually sitting here and doing it for him. So my name's Simon Dickinson. I'm the BIM Technical Manager here at Graitec. So Revit's my primary product, so it's one of my favourite subjects to talk about. So if you've got any questions as we go along, please do post them. I can't guarantee to answer them as I'm going through the presentation, but I will respond to you in due course after the presentation as well. Okay, so let's start to have a look at sort of some of the tools that we've got actually in Revit. So what I'm going to do is I'm going to start out from scratch on a blank drawing, and the first thing I'm going to show you is the fact that we've actually got energy analysis tools now built into Revit that not only work further down the line on the actual proper building model itself, but we can actually start from a very early stage in the project. Even from, in this case, I'm going to do something from a conceptual point of view and show you the conceptual tools that we can use to basically start to have an idea of and a feel of how our building is going to actually perform. So what I'm going to do is I'm actually going to use the mass tools that are built into here. This doesn't have to be the tools that are actually here. We could be using the mass tools from the new mass, so we could create a conceptual mass here and we can put them in. The other thing that we could be doing as well is we could actually be pulling in a mass that's maybe been drawn in another product, whether that be 3ds Max, and pulling the mass into the mass editor and converting it from a SAT file. We can even take SketchUp files to a certain degree and pull the SketchUp files in and use them as well. There is workflows to actually get that information in. But what I'm going to do is I'm going to start by creating an in-place mass within this environment. If we just have a look at what I've actually got set up here at the moment, is I've just got some let's cancel that a second. What I've done is I've actually created some levels. So it's just a blank drawing with some levels, and I've set these levels up just to help me build my mass model. So go back to my ground floor and let's create an in-place mass. Click OK. It's automatically turned my mass visibility on, so I can now start to draw in here. So I could draw the outline of my building like so. If I actually go to a 3D view, if I just create a form from there, we do actually have quite a nice tactile environment that we can work in. Quite push and pull, dare I say it. It's not exactly the same as SketchUp, but it is quite nice. And we can start to manipulate our design. Yeah. So I can actually build up my building space. What I can then do is if I just go finish on that and I actually select this building, we can actually now start to take our mass and add a bit of building intelligence, if you like, in here. So I can start to create some mass floors, and I can specify which one of these levels is actually the floors. Level 10 is going to be the roof, and click OK. And as you can see, it's now started to subdivide my design down. And these are actually floor spaces, even to the point where from this very early stage of design, I could actually come in and start to do a schedule from my mass objects. And I can actually do a mass floor schedule. So it can have its level, maybe its floor area, its perimeter, its volume. Okay. So we straight away we're actually getting information about our mass, and this is critical to when we start to do the energy analysis, because it does need to understand a certain amount of aspect about this building. Now Next thing I might want to do is, I'm here on site. Let's just specify our true north location, because again, even at a early conceptual stage, it's important that the building understands its location. It's going to be using weather data to actually start to generate this. So let's just rotate true north, and we'll have our building at this angle to true north. Okay, the next thing I might want to do is actually specify its location. Okay, so if I come into here we go, this is our current location map, centre of London, and these are the local weather stations that it's actually picking up. Okay, so what I can do is, let's just zoom out. I'm actually based just north of Bradford, between Bradford and Leeds, in a little place called Shipley. So let's just come over here and let's just place this in my exact location. Okay, so I can come in, and we're actually based just here in this area. Okay, so Saltmill Road, that's exactly where I am at the moment. Okay, so that'll actually place that there, and it will actually now work out where the nearest weather stations are. Okay, so these are all the nearest weather stations to my current location. Look, so the weather stations are very useful because they're going to give us historic data. So when it starts to analyze it, it's going to know what the average temperature is on any particular given point of a year. Okay, and I can specify which weather station I want to use. Now you might say, well, why doesn't it just use the closest one? The closest weather station isn't necessarily the best. I've had cases where there's been a very large hill between the weather station and the actual site, which basically means anyone that lives anywhere near the Pennines or anywhere near a large hill will know that whatever the weather's doing on one side, it can be very different on the other. So it's quite important that we have got the option to choose exactly which weather station we wish to use. So my building is now set up. The shadows are going to be correct for its location. So if I actually turn my shadows on, if we just actually turn these on, if I go into my sun settings, just make sure that we're actually our correct location today at 1500. So that is exactly how the shadows would be at this exact moment in time. So what I can now do is, now that I've actually got that mass set up and I've got the location of my building, I can now start to look at doing some analysis on this. So what I can do is, I've got the basic energy analysis tools here, which we're going to be looking at, and I can now start to look at what the energy settings are. So I can choose my building type. We can set where the ground floor is. We've got some information about our detailed model. We'll come on to some of these settings later, but for the time being, I can ignore these for this particular mass. The analysis type, I've got 3 choices in here. I actually just want to use the conceptual design. And what we've then got is, we've got some other tools in here. So it's going to divide the perimeter. Basically, it's going to put an offset back in there by 3.6 meters. I'm telling it that the building, I want a percentage glazing of 40% glazing for the whole of the building. I've got the same option from here for the skylights. Okay, and I can basically start to get this to generate a conceptual model, even though I've not put any windows or anything in here yet. I can click OK. Okay, and then we can come up here and I can create the energy model. So this has now generated an energy model based on the parameters that I gave it earlier. Okay, and you can see now where we've got a building core, so that's where it's divided the perimeter out. But this is a full conceptual model. I even have the option as well, if I just go back into here, is I can actually adjust what the conceptual construction is of this particular building. So what we're saying here is, I've just drawn a box. What's it made out of? Is it made out of cardboard? Is it recycled wood? Are we going to make it out of hay bales? We can basically come in and start to give it an understanding of the makeup. Yeah. So we need to. It's not going to give me the exact properties of the hay bale, but I can say, right, well, it's high mass construction, typical cold climate, and we can come in and we can start to change the level of insulation. We can come in and change what the typical mass roof's going to be created from. Yeah, we've got the glazing. Is it just double pane clear, no coating? Is it triple pane? I'm actually going to set this to single pane clear, no coating, just to start with. Click OK, and we can set that up. The next thing I can do now is I can send this out to the cloud. Now, the majority of the energy analysis and pretty much 90% of what I'm going to show you this afternoon, it uses the cloud services. But for most of the analysis that we're going to do, particularly on most of the energy, it doesn't use your cloud credits, but you do need to have an active subscription account for Revit to be able to actually run these. Okay, so what I can do is I can now go to my little cloud icon and I can run my energy simulation. And what this will do is it will actually upload this model now. So let's have this called this demo mass. Okay, hit continue, and this will now take my model and upload it onto the internet to start doing some analysis. Okay, now what I'm going to do is I'm going to leave that running. I'm going to show you how we can customize this mass to have windows where we want it and not necessarily where Revit wants to put the windows. So at the moment it's calculating this model and it's putting these windows and areas in based on the 40% glazing. So what I'm actually going to do is I'm going to change all this. So I'm going to come back into my energy analysis. I'm going to have a core boundary of 0. I'm not going to divide the perimeter. I'm going to change my total percentage glazing to 0. Okay. If I click OK, we'll now notice that it's actually got no windows in there. If I just delete my energy model and recreate it, yeah, there's not a lot of information in there at all. What I can do is I can edit now my in-place mass, and once we're into the edit mode, we can start to split surfaces. Yeah. So if I select a surface, I've got the split surface tool. So some of you may have used this within Revit for colouring in different sections of walls, etc. Changing the material, putting infill panels in, maybe even drawing carpet or floor coverings onto floor surfaces as well. So what I'm going to do is I'm just going to choose my split surface and choose the surface I wish to, well, surface now is already set up, so that's selected, sorry. And I now can start to draw in there, yeah, some additional design features. So imagine I wanted some quite tall glazing in here. Obviously, if you want to be a little bit more accurate in the way you do that, there's nothing to stop you actually coming in, selecting this and being more accurate in the way that you draw. We can use reference lines, etc. So there's the first part of my glazing. So now if I just go back to my 3D view and just go finish, yeah. If I now go back to my analysis and create the energy model, you'll now notice that that is now glazing area. So I can start to split this down and I can control this. You'll notice just over there, I just had a window pop up to tell me that the energy analysis is actually finished. So what I'm going to do is I'm going to go to my results, okay, and let's just go back to this object here. So we've basically, I very quickly drew up a building, obviously rotated to where we want, and then ran some analysis on it. And what we'll find is it's actually come back with an awful lot of information, even from a conceptual design phase, on this particular building. So it knows its location. We've got the GPS location there, exactly where it is. We've got the exact weather station that the data is actually coming from. Now, it mentions here that the maximum temperature that we get to normally in Shipley is 28 degrees. During the year, the minimum we get to is normally about -5. Obviously, this is within a 5th to 95 percentile. And with some other information as well. You'll notice as well that the costings are actually in dollars. If I'd have actually logged into Green Building Studio first, I can change the default units. So you don't have to have it in dollars. We can actually change this to pounds sterling as well. Okay. And as we go down there's some very useful information. Yeah, we can also change the price of our fuel as well on the Green Building Studio. But what it's going to start to do is it's going to start to give us a really good understanding of how this building is working. So here we have the annual carbon emissions for the building, net CO2, etc. We've got the annual cost for the fuel, so what's it using more electricity to more fuel. Okay, and as we go further down, we've also got what the monthly heating loads and the monthly cooling loads are. So this information has been generated automatically in the background based on our weather data. Okay, we can change the way that the building is heated and cooled. That information is within our conceptual design. So what sort of air conditioning using, etc. So we can start to tweak that to get a better understanding of how the information is going to work. It'll even tell you when, obviously, the fuel costs are going to be most high, and it'll also tell you when your cooling loads are going to be the highest as well, particularly through sort of like the peak loads. We also then have some locational information. So we've got information with regards to the wind rows, so which direction the wind's coming from, what's the speed of the wind on average, yeah, and we've got the annual, etc. Basically, all of this information that we're being shown at the moment is all based on our location. Okay. What we also have at the top here, there's a few extra tabs. Look, so we've actually got solar and energy cost range as well. So what we're starting to look at here is it's giving us what the energy cost range dashboard is based on that building. So we can start to look at our designs, and we can reiterate our design as well. So it's not about just doing one. We can then start to tweak our build up of our mass model, maybe change the way it works, add a little bit of solar shading to that, and then we can reanalyze that. So we can redraw, and we can draw other facades on there as well. If anyone's using an iPad, you may have come across a product called Formit. Formit is like a really cool building design tool for Revit. That can then take the same information, but we draw in Formit and our mass models there, and we can pull them straight across into here and start to do the analysis on that. Formit as well, although it is set up to work predominantly on a tablet, whether that's an Android tablet or iPad, Apple device, there is an internet version of it as well, so you can run it on the internet. If you've been to some of our launch seminars in the past, you may have seen us actually demoing this. Okay, so we do have other tools on here as well, okay, that will start to give us cost breakdown. We did also have a few months ago, it wasn't very productive, we did have some suggestions. So within our results, we could actually get to give us a suggestion on where heating and money could be saved. We've removed that now because some of it wasn't giving a clear picture. Okay, so we've got our mass model there and successfully being able to work our way through. As I mentioned, we can then start to customize exactly how this works. If I just select the mass again, just to edit the in place, you know, there's nothing to stop me being able to, let's add a, I don't know, bit of solar shading. Notice that was a drawn object, yeah? So there we go. So I can even start to add a bit of solar shading onto here. Select that, let's just move that bit up, bit of the shape, yeah? So we can really customize our designs. Hit finish. That obviously would now start to give me shadows in there as well, etc. So if I turn on my put the shadows on, yeah, we can start to see the solar effect. That is going to be affected by our mass model when we go to analyze as well. Okay, so even from an early conceptual point, we can now start to look at exactly how this design is going to look. For those of you that have never played with the mass tools, I highly recommend you have a look at them. They're very, very powerful. We also have tools in there to take this forward, so we've then got the ability to use the mass to start to generate building elements as well. Okay. A few years ago, though, we changed the way that the energy analysis works. So this was the first thing that we actually had within Revit, was the ability to create a mass model and start to analyze it. But of course, it was only giving us conceptual information. What would be really nice if it started to give us a little bit more or a higher level of information. Yeah. So what I'm going to do is I'm just going to switch over to a different file. So here we have another model. Yeah. So this is my office block. People have seen my demos before. They're probably going to recognize my little office block. And this is the mass model that was listed beneath it in the early conceptual stages. If I just go to the 3D view here, here is the model in a slightly more completed fashion. So we've now got as walls, etc. Now, we probably about 3-4 years ago now, we re-changed the way that the materials worked, and we started to add assets to materials. So I've got a wall here. If I just go into the wall, into the in fact just onto this page, you'll notice that down here under the analytical properties, I've got a heat transfer coefficient, a U value for this wall of 0.3176. So I'm now getting the U value information about this wall. Now what makes this value very clever is that value isn't generated by me just putting a value in based on the whole wall. It's based on me putting a material value in for each of the layers that makes up my wall in here. So if I go to my finish 1.4 and I look into here, notice we have in our material editor assets. Okay, so I've got an asset in here called tile terracotta, which has actually got the thermal conductivity value for that particular material. And I can start to set up each of my materials in here with one of these assets. Now, if you haven't used the material editor much, just be very careful what you do when editing assets. If you imagine this material here, even if I duplicate it, it's still using these same assets. And these assets aren't unique either. So if I came in to the thermal properties of this panel terracotta 2 and changed, I don't know, let's change this immersivity to 0.6. No, there we go. If I now go back to the panel terracotta, yeah, that's 0.6 as well. So you've got to be very careful what you're doing when you come into here, because if you're changing an asset, that asset might be linked to other elements within the system. So do be very careful. We do have issues here where people will change one asset and then discover the fact that why is it not working somewhere else. It's the same with the appearance asset as well. If you change that, it is also going to be affected as well. Okay, so what I'm going to do is, if you do want to change that, hit this duplicate button here. That will now create that as a terracotta 1. If I now change that to say 4.4, if I go to this one, it's 0.5. So just be aware that the assets are not unique. The other thing you can do with the assets as well is, if you actually search for that asset, so if we actually go to the replace asset, here's our asset browser, there's nothing wrong with creating your own libraries. So if I just call this asset Graitec, okay, and then I can drag and drop assets into here. I can then customize them and rename them at this point as well. Okay, so by creating each of my materials in here, it's going to slowly but surely allow me to get a total thermal mass for our wall. Okay, and this total thermal mass is the thing that's then actually being converted actually into the U value that we saw on the last screen. Okay, so we can now start to build up an intelligent model now, where the actual makeup of a building has got thermal information required on it as well. So what I can do is, if I just go to back to my default 3D view, within here now, if I actually select my analysis, yeah, I can go into my energy settings. Now, instead of using the conceptual mass, which is what we've just done on the other project, I can now start to come in. I can start to use the building elements. The other thing I can do as well is I can either tell it to use this conceptual construction, yeah, so the same way as I did before, where I'm saying it's just a lightweight type, mild climate, etc. Or I can be more accurate and I can tell it to include the thermal properties based on this surface. Yeah, I can also set the complexity, yeah, of the actual model. So complex with mullions and shading surfaces, the more you change this, the longer it'll actually take, but the more accurate the results are going to be. It's not going to give you Part L compliancy, so don't be expecting it to come back and give you every last bit of information you need. The concept behind the energy analysis here is to give you an idea of how your building is going to perform. Okay, so I'm going to leave that as it's set up. Notice this is also set up as a 0 offset and a 0 core. I can click OK. What I'm now going to do is I'm just going to create the energy model, yeah, from the information that I've applied. And we should find now we've actually got the energy model being created in the background. Okay. Notice it has ignored the shading, so my brief delay, because I told it not to. Okay. Once I've created my energy model, I can now send this off and then use the existing analytical model, or I could update it. Yeah. We'll just update that in case I've created any changes in the cloud. Yeah. So now I can go OK, and we can upload this. Now this model I've already set up, so it's an existing one. So it's now going to upload this, and it's going to create this as Office Block Architects 2016 with mass in 2. I want to create new. I don't use an existing because it'll override that. But what this will do is it'll create 2 separate models, and I've probably not changed too much on here, but we'll see. So I can then compare the results, and we can see which design is going to look the best. So I'm just going to leave that to go up, and hopefully the power of the cloud will mean that I actually get my results back relatively quickly. I can come back into here. Let's just change that to complexity mullions just so you can actually see. So I'm just going to delete the energy model that's there, and then let's just create a new one, and hopefully this will come back, continue working. So this one now, although it's not showing the shading, will actually be taking into account that when I actually run the analysis. Okay. Now, not many of you will be aware of this, but Autodesk have just released Revit 2016 R2. So we've just had a second release for the 2016 version. This is only available to people on subscription, but I believe most of you probably are if you're using 2016. So that's downloadable from your subscription center. Now what they've done in the new version is they have actually added a couple of new features. In one case it's actually energy zoning, and this is done automatically now. So what we can actually do is, in fact I'm just going to go back to my mass, so we'll do it in here first. So what we have here is within, oh that was nice and quick, look it's come back already. Cloud's obviously quiet this afternoon. So within this model I can actually change the information that I'm actually trying to get, and we can automatically get it to generate thermal zoning information. Okay, so within here we can actually start to divide perimeter zones, etc. If I actually go to this particular setting, and let's just force it to create the new energy model. When it actually creates the energy model now, it will actually take into account, if you notice the colouring, so the top of it's a slightly different colour, so it's actually showing me where the hot spots are and the thermal zoning within here as well. This should help further on with the air volumes, etc., from a visual point of view as to which areas need the most or the least cooling and heating within the building as well. I'll also show you a second how Revit's always been able to actually generate this information, particularly if you've got Revit One Box. If you guys out there are only running Revit LT, none of this analysis tools are there. You cannot do energy analysis in Revit LT. The only thing you can do is, I believe you can still export GBXML to send off to someone that would be using some other analysis package, whether using something like HeaverComp, IES, virtual environment, stuff like that. But the tools are not built into that. The other tools that we've got, which I'll show you shortly, are only available in the One Box product, i.e. the version that comes with one of the design suites, or in Revit MEP. I'll show you them in a second. So this idea of thermal zoning becomes quite useful from a visual aspect, so you can actually see how that model's going together. Skipping back to the results that we've got, because we've just had the results in from the Office block. So what I want to do is I'm just going to come into here. Yeah. What I actually have is I've actually got the 2 versions of the Office block. Yeah. And I can start to compare these. Okay. So these are my different elements. This model here, the reason it's coloured is because I told it to also add in there the mass model, so that it was actually analysing the thermal zones as well. But as we come through, it will actually tell me which building is the most efficient based on my design. Now, as you can see, I never changed my settings from either version. But if I'd have changed the settings, whether it's the insulation in the wall, the level of insulation, etc., maybe I've rotated it slightly so that the glazing is facing north more, that would make an effect on all of these values. And we can come in and we can start to then have an understanding of, if we do make a change, where that change is actually going to come in, what the effect of that change is, and what benefits we can gain from that as well. Okay. So the analysis side of being able to compare is very, very powerful. So if I come back to this building now, one of the things that we can do is, if I just make sure that I've got them all set up, so make sure I've got my room spaces in here. So I'm just going to go to annotate, and let's just put a fill legend in here, and we'll base that on rooms, room name. Okay, so we can see where I haven't got rooms. Let's just put let's create a room in here. Okay, daylight in room is fine, so we can put that on there. Okay, what we can then also do is just make sure that I've actually got my room set up on the other levels. I believe I have the second floor. Right, just set our rooms up in here. So if I go to room and use my existing rooms, so male WC and female disabled, kitchen, let's just delete that room that I accidentally placed out there. We don't want that one. And technical workshop, circulation. Okay, so I can set my rooms up in there. Now what we can do is, if we actually go to analysis, we've actually got spaces, yeah, and I can start to create spaces in there. Now what I'm going to do is I'm just going to place spaces automatically, yeah, and what that's done is it actually takes my rooms and it creates these into spaces. Now once you've actually started to, you've created your spaces within your building, we can actually start to look at heating and cooling loads. And if I click on here, we'll notice it's using the same information as I used before. So I can come in and I can specify the building services, is it a VAV, single duct, forced convection heater, these loads in there, yeah. Central heating with radiators even, okay. I actually want it to be HVAC because I want to actually better calculate the heating and cooling load. So we've basically got our zones in here and our levels, okay, and we've set the ground floor. If I calculate now, what it will do is it will actually generate a report, and this report's very, very in-depth. It's actually been through my entire building. It understands the heating and cooling loads, it understands my location, yeah, it understands exactly where the building actually is, but then it also understands the different zones. It understands each of my rooms that it's created. I could have obviously renamed these, but if I go to say zone 2, so number 2, it will actually start to look at that room and it understands the wall areas, the window areas, all the information regarding that particular room, including what the heating and cooling loads are, and it will even then calculate what the peak heating airflow needs to be. So I know that this zone needs 85.6 litres a second. The nice thing then is when I do start to design any HVAC systems in there, it will tell me if I'm actually hitting my target, if I'm above my target or below my target. So very quickly, even on this point here, these tools will actually give us a lot of feedback about our building. Okay. Now, another tool which has been released, it is a subscription tool, so you would need to download this separately. But what we actually have is, and you can see it up here at the top, is we've actually got some lighting analysis tools now. Now, these use, it's using LEED values, it's not using BREEAM, which we use in the UK, but LEED was actually developed out of BREEAM, so the BREEAM standard was developed first, and then basically the LEED standard in the US was developed from our standard. So there is a slight difference in the values, but in the information that's required and given back, but it's very, very similar. So what I can do is, if I go to a 3D view of this building, I can start to run analysis. Now, the only thing to watch out for with the lighting analysis is this does cost cloud credits. And I think it calculates it per floor. So it's 1 credit per floor of the building. So this building's got 3 floors, therefore it's probably going to cost me 3 credits, okay? And we can go through this and see how this works. So I'm just going to go continue, okay? It's going to take the location of this building. It's going to take into account where the sun's coming from, okay? And it's actually calculating this as of September the 21st, but you can change this. So this is using my solar study settings, so I can actually change that. You'll notice in the moment it's only got the LEED standards. If and when the BREEAM standard are coming, I don't know. We can change the quality as well from high to low, and it's going to give me the fact that I need to use 3 of my credits. But as you can see, I've only got 8.5, nearly 9 million credits left, so I don't think it's going to make too much of an impact in that. Okay, I can get to email me as well once this is finished, and then I can hit start. It'll now upload that away, yeah. And I've got to be careful that I don't affect this where it's going up, so it does need time to upload it, and it's doing it in the background. So I can still carry on working as that uploads in the background. It will then start to calculate it, and what it'll do is it'll look at the where my windows are, it'll calculate where the sun is, and what it's actually doing in the background, if I just go to my renderings, you'll notice here that it's actually generating these views, and these views are actually my different levels in the building. So that's actually the windows up on the 3rd floor. That one looks like my 2nd floor when it finally uploads. It's actually struggling to get that in. Yep, so that's actually the 2nd floor, and that's the ground floor of the building. So it's actually looking at how that light's actually penetrating the building through the areas. We can see there just the bottom of the staircase, which is affecting how the light actually goes dark. So we can start to now see the lux value for each of them. Now, as well as it drawing these in as a 2D, what it will also do is, if I go back to my Revit model, this might not work because I've just updated it, but we'll find. If I just generate results, because I did, now it's just waiting for me to finish this. It will actually then superimpose them images into my 3D view. So I can start to see where these dark and light spots are actually in my 3D model, and we can do that in a 2D view or in 3D. So again, it's just another set of tools that are giving us some more information about how the light's going to work as well. We have actually got the same sort of lighting analysis toolkit within 3ds Max, and it has been there for a fair few years, and it's certified by the Canadian government for the results. So we do know that the results are incredibly accurate. So even if you're not running Revit 2016 and you can't get access to the lighting analysis plugin, you can still use the lighting analysis toolkit in 3ds Max, as it's now called, or 3ds Max Design, as it was prior to 2015. Another thing, just out of interest, while we're talking about rendering in the cloud, so basically the service here is actually using the analysis that we've actually got in cloud. Now what you can do as well is, if from any particular view, if I just went to here and let's go to a camera, if I actually place a camera in here, what I could do is at this moment in time is, if I actually go to render in the cloud, when we send this image up to be rendered, we also have the ability here to set, rather than have this output type as still, we can actually have it as an illuminance value. So this is doing a similar sort of thing, but this will actually render this and show us the dark and light spots on all surfaces within a 3D view as well. So it is calculating a similar sort of effect. Again, just be aware, if I go this to maximum illuminance 16 megapixels, it's going to cost me 16 credits. Okay. If you actually put a value on a credit being around about £1 a credit, it's going to cost me £16 to run this analysis. Okay. Another thing that we've got as well, just to show you, this was added into the cloud rendering a few months ago, and there's not a lot of people know about it. To be fair, this has got absolutely nothing to do with energy analysis, but it's a very, very nice little feature that we've added. So what we have is now is whenever you render an image, so if I just go to this one, yeah. Once you've rendered it in the cloud, you can then render it as a stereo panorama. If you do this, you can then download it to your phone and use these sort of cheap cardboard goggles that you can buy. I actually bought a set of stereo goggles off of Amazon that my mobile phone just slots into, about £10. These will then give you an immersive 3D image, and you can actually use the potentiometers within your mobile phone to view that. It doesn't have to be an iPhone, it will also happily run on any Android phone as well. If you've really got a lot of money, you can obviously buy the Oculus glasses, but you don't need that. So this is really good at giving clients and even yourself just a really good understanding of how your building is going to work. Okay, so let's just have a look. How far off are we getting them rendered? So these are now basically being rendered. Typically the rendering has slowed down. So, and because I've forced it to upload, it's actually changed them settings. Okay. But when they come back, which might take a while, so we might not have a chance to show you that. As I said, we can simply then go to our analysis, and we can then generate the results, and the results are what actually load that in. So if I just come into there, right, so that's going to wait for the current one. What I'm just going to do is, while that's going, I'm just going to do a save as on that project, and we'll just call that one Mass 2. I did actually save my settings on my previous one, so let's just go File and go to that one, and let's see if I can get to generate the results on that. Here we go. So this is one before I made the changes. Okay, it's actually failed on the lighting criteria, so that's always good to know. But this is now giving me the information about exactly what's happened in the background. Okay, so this is slightly out of date model. This is the one that I was playing with earlier this afternoon. Let's just spin it around there. Okay, and you can actually see now where it started to superimpose the lighting information, and we can start to see now where the light spots and the dark spots are appearing. And we can also see the level at which it's calculated that information as well. So it's calculated that at 1200 above ground. That, if I just go to this elevation, select that level, is the computational height. Look, so whenever we do any computations, whether it is the area, room volumes, room areas, sorry, not room volumes, but room areas, we use this computational height, which is set up on the level. So the fact that that 3D view has got that here, that is being based on the fact that my level computation for the ground floor is at 1200. So we can change that as well, because obviously depending on the height from that, it could give us a different impact if I was calculating above this landing height there. Okay, so there's a lot of tools based in the Revit package that give us an awful lot of additional functionality to start analysing our building. As I mentioned before, it isn't going to give us Part L. It's not to that level. What it is, though, it is accurate information based on the information that it gets. So we can very much look and start to understand how our building is going to react to the environment in which we are going to put it in. The light analysis is really useful. It's going to give us our lux values. Notice that there seems to be a massive gap there between the 6,000 lux on my second floor and the 3,000. You can, when you start to run the analysis, if I just click next, I won't do this, but we can start to look at what the thresholds are, okay? So we are getting some light beyond that, okay? We can also rerun this where maybe we only wanted to do a single level as well. So the tools that we've got are incredibly powerful. The fact that the majority of them, as long as you're on an active subscription, are pretty much free to use other than the cost of the subscription. So you can run as much energy analysis as you need on a particular building and start to analyze every different change, whether you're changing the thickness of a glass, maybe you're taking it to triple glazing from single glazing, whether you're adding solar shading, whether you're actually putting a more insulated building structure together. Is it timber frame? Is it a timber clad building? All of these obviously can be taken into account by the energy package. So hopefully that's given you a really, really good insight into the power of these analysis tools. I hope you've enjoyed this afternoon's session. It's only a short one. There's not an awful lot of tools in there, but they are quite powerful, the ones that are in there. So thank you for your time. I do believe I had a couple of questions, so what I will do is I will answer them afterwards, and I'll send you an email out to the people that have asked them questions. Again, thank you very much for your time, and see you in our next webinar. Thank you. Bye.